Hi. In this example here, we're going to look at the dihedral angle and get an alternative approach to actually obtaining the dihedral angle. Okay, so here we have two intersecting planes. We've got A, B, and C, and we've got D, E, and F. Okay, so like the previous videos, what we're going to do is we're going to look at an alternative way of obtaining the dihedral angle without using horizontal cutting planes or vertical cutting planes. It's just an alternative approach. Okay, so the first thing I'm going to do here is this. I'm going to take my triangle A, B, and C here. So there's A, B, and C, and I'm going to take a level line. I get point N, I project it up here, and I join C to N. That is my true length. Then I'm going to go in the opposite way, still on this triangle A, B, and C. I'm going to take a level line from C, take it across, bring it down, and therefore there is my true length. So now I've got two true lengths, one in the elevation and one in the plan, on the triangle A, B, and C. Then I'm going to do the exact same on the triangle D, E, and F. So there's point E. I'm going to take a level line with my T-square. I create point M. I'm going to project it down to the plan. Okay, so M is on the line F to D. So there's F to D. Therefore, that's my true length. I've just colored in red there, so I'm written down here true length. The next thing I'm going to do is I'm going to do the opposite. From F, I'm going to take a level line from F. I'm going to project it up, and now I have a true length of a line up here. So now what I'm going to do is I'm going to forget about that triangle now for a minute. Okay, those two intersecting triangles. And now I'm going to work on this imaginary or this third plane that's common to both planes here. So here what I'm going to do is I'm going to pick a point P at random. So point P down here is at random. And all I'm going to do is I'm going to draw a line perpendicular to the true length of a line here. This one perpendicular. And likewise, I'm going to go perpendicular in here. Okay, so perpendicular here from point P at random and perpendicular here. Okay, now I've got two lines which are perpendicular to two lines. Up on the elevation, I do the exact same thing. From point P, I'm going to go perpendicular to this true length of a line here, and I'm going to go perpendicular to this line here, this red line, or this true length of a line on the plane D, E, and F. Okay, so what I have now is I've got two lines which are going perpendicular to two lines. Okay, now what I'm going to do is I'm going to create a plane out of those. So all I do here is I take a random level line up here, point 1, 2. I find point 1, 2 down on the plan. So 1 is going to be down here. Okay, likewise with 2 is going to be down here, and I had to put a little extension onto my line here, okay, to obtain point 2. So now what I have is I've got a triangle P 1 and 2. I've got the plan of the triangle P 1 and 2, or I've got a plane. Okay, so now what I'm going to do is I'm going to find the true shape of that triangle. I'm going to forget about this now for a minute. I'm just going to deal with my little triangle P 1 and 2 here. So if I look along this true length of a line here, I know what I'm going to get. I'm going to get a point view. Okay, and I'm going to project out point P. Now because these distances are so far away, I've just used the line 1, 2 as a datum line. Okay, so everything is going to be relevant from that datum line there. So in other words, point 1, 2 is on my datum line, so there it is on the x1, y1, and point P is the distance from there to there. We'll step it up there. So now what I have is I've got an edge view, right? I've got an edge view of my triangle P 1 and 2, and if I look down there at that edge, I know what I'm going to get before I draw it. I know I'm going to get a true shape, because that's a property of looking along or looking at an edge. I'm going to get an edge of a surface. I'm going to get a true shape. Okay, so I know I'm going to get a triangle. Okay, because the original was a triangle. So how do I get it down here? So all I do is I take the distances. Okay, I take my distances from the x1, y1. In other words, if I step out from there, there's point 1, and I step it out here, there's point 1. Likewise with point 2, and likewise with point P, they're the exact same distance, and I end up getting this true shape of a triangle down here. And we know that a true shape is made up of true lengths. Okay, if I put the extension on here, these lines here, now I have my dihedral angle between those two planes, because we said a few minutes ago that a geometric theorem tells us that all planes containing a line perpendicular to another plane are themselves perpendicular to the other plane. So if the two lines, one perpendicular to one of the given planes and the other perpendicular to the other given plane, they intersect at a given point, they determine a plane perpendicular to each of the two given planes. So what I'm saying is this: the dihedral angle is an angle or a triangle perpendicular to two existing triangles or two existing planes. Okay, and then finally I've got my H's and V's. So H tells me this is an elevation, V tells me it's a plan. Okay, so down here when I look up along here, I still have my H and V, so I know that tells me it's an elevation. Okay, because elevations are relevant to the horizontal plane. And down here I've got my horizontal there and vertical, so this tells me this must be a new plan or an auxiliary plan. Okay, so that there is my dihedral angle. And finally, just to finish this off here, another way of completing the question would be if I swing this down here, so point P is going to come down there. Okay, and then all I'm going to do is I'm going to simply set up a track. Okay, I'm going to set up a track system and I'm going to project back point P, and because P has moved up there, it's going to move down here and it's going to go parallel to the XY line. Therefore that there now is point P. So therefore if I join that to point 2 and this to point 1, that there is my true shape of the triangle P1, 2, and it's also the dihedral angle between two existing intersecting planes. Thank you.